Thank you, everyone. Uh, as I already got introduced, my name is Riddhi, and I'm going to talk about Web 3.0. Now, I am new to this myself. How did I learn about this, and why did I learn about this? Because how many of you in this room have played Winja CTF yesterday? We have few people. So you remember that we had Web 3.0 challenges, right? So they were created by me, and I created them because I wanted to learn about Web 3.0, and what best way to learn about something by experimenting with it, right? So there were few learnings, there were few things I observed while creating these challenges, and that's what I am going to share in this talk. And most important thing, why did I choose this topic? Smart contracts could be leaky, because I tried hard to protect the flag. I created the challenge, and I was like, my challenge is done. And then I realized that the flag is just lying there for everyone to see it. That was a learning. And how did I make that? I was wondering, how do I create this challenge then? So what did I do? Everything I'm going to share with you. So this talk is about sharing experiences with you about the things that worked and that did not work for me when I was working with smart contracts, how I leaked the flag, and what was the fix I applied to prevent leaking sensitive information. So this screenshot that you see, and you see the flag lying there, right there, anyone and everyone around the world can just see the flag. So what would be the takeaway from this talk? First thing is, like, Web 3.0 is absolutely interesting. Some say it is totally decentralized. Some argue no, it is not totally decentralized, because if anyone has experience in Web 3.0 already, if you have, you know that we need to use Alchemy. Without that, we cannot proceed. And Alchemy is a centralized server. So can we say it is totally decentralized? Not yet, maybe, but maybe in future it will become. So it is interesting for sure. Why is it interesting? Because right now the model that we follow is client and server architecture, right? Server is something, what do we, either we have our own servers, which nobody, I think, uses these days, or we have AWS or cloud servers, right? And we are totally dependent on them, cloud providers. But the Web 3.0 is an approach wherein there is no need for AWS, Azure, or any such providers. So you can straight away deploy your functions, and then you can use them. And smart contracts is the way to do that. Now, there was major problem with Web 3.0, integer overflow, which could be really dangerous sometimes. So it was possible in this, but so I thought that it would be a very good challenge to create something around integer overflow, and that's what I was trying to do. But then I realized I had to literally hardcode a lot of things to make this integer overflow work, but still it didn't work, and it was giving some error, which means that something had changed in later versions, and we'll take a look at what is that. And then finally, information leakage. As I mentioned earlier, the flag was leaked, and not only flag, even if you use private variables, that does not mean that your information is safe. Private variable is just means that your function, and how do you access the variables when you are using different functions. That's that's where private variable makes sense, but not in the sense that it is making your information private. So who am I? At this point, I'm a freelancer, but soon I'll be joining Qualcomm. I have a history of I'm not into one thing forever, so I have done C++ secure coding. I was an instructor for that. I have played the role of security analyst, consultant, scrum master, automation engineer, quality engineer. So a lot of things, varied things I have tried. At leisure, when I'm not working, what I'm doing is I have developed an app called Vyapi, which is an Android application, vulnerable application, and it's there on my GitHub repo if anyone of you want to try. So why did I create it? Because I was trying to learn mobile pen testing. Then I have spoken at few conferences, and I'm also community volunteer for Winja. So whoever has attended CTF, yesterday Winja CTF, you might have seen me. Social media handles, in case you want to reach out to me, these are my handles. Okay, so first thing, integer overflow. How many of you are comfortable with the concept of integer overflow or overflow in general? I'm sure most of you would be. Yeah, so overflow, as you can see, is like there's a little space and we try to put more information, things can go wrong there. We can overwrite addresses and do a lot of things there. For example, now this is an example from this .sol that you see. This is the extension for Solidity file, right? This is how we write smart contracts. Now, this is not the complete smart contract, but this is just one function. Now, in this function, if you see the things that I've highlighted, there is int 256 and there is uint 256, right? So before coming to this, I'll just show you quickly, run you through this diagram. What does this mean? So you see there is a signed int and there's unsigned int. And how integer arithmetic works is, how does overflow work? In unsigned integers, there is no negative numbers. In signed integers, we have positive and negative numbers. So if you take a note at all the red ticks, right? So let's take, for example, in the case of unsigned integers. So you see uint max and uint min. Now uint min is 0 and uint max is when all the bits are 1. You have, let's say, 8 bits. So all bits are 1. That would be maximum value. It cannot be more than that ever. What happens if you add 1 to it, right? What happens? Because there is no place to represent the number, so that is truncated or it overflows. And then it rounds off. So if you remember the circle, when overflow happens, uint max plus 1 will become 0, which is very small. And if you're trying to do a comparison on this, then things could go wrong. Similarly, if in signed integer, in case of signed integer, if you see int min and int max, they are lying very close to each other. So int max plus 1, if you do, it will become int min. It will become a very small number. So this is very tricky, and you can never be sure whenever you are dealing with integers, C, C++, then these are very common things. This is very common, and you can never be sure that you have coded correctly. So integer overflow is a real problem. In case of smart contracts, now this is what I was trying to do. So I deliberately used int, which is signed integer, and uint is unsigned integer. Now, when I pass signed integer, let's say I say -1 is a signed value. And if I'm using it and converting it into an unsigned value, then there is it has to be a positive number. So it turns into, when this conversion happens, just remember that it becomes a very large number, and overflow might happen. Now there's another condition in here: balances seller minus equals to price. So that arithmetic is happening. I'm subtracting something. So as we saw some time back, either subtraction or addition can lead to overflow, integer overflow. So this was my function wherein I was trying to force integer overflow. So yeah, this is just a summary. So here, if you can see, int max plus 1 becomes int min minus 1 becomes int max, and both the cases are overflow conditions. How do we deploy a smart contract? So if you have written a smart contract, I was using hard hat. So if you are using hard hat, and you will have to write a deploy.js file script, and then this is how. There are different networks available. Rinkyby is there, Goerli is there. These are all test networks. I'm obviously using test networks because I don't want to use real ethers. But if you want, and if you have, then you can use real networks as well. But this is a test network, and this is the command that we run, and it gets deployed. The moment it deploys, you'll get an address. You can get an address, and you can see integer overflow address. The one which starts with 0x, so that address you get. Now this is the address. You can say that it got deployed on your server, and now anyone can access this address, and they can access your function and whatever is lying in there. Now this is ABI file. It gets generated the moment we deploy a smart contract. Now what is ABI file? It tells you some information about the functions that exist in the smart contract. For example, in this case, you can see we have this sell article, right? That is the function, and then there's price, there's description, there is name. Let's go back to this smart contract and let's compare. So you see We have price, description, name, seller. These variables are there, right? And cell article is the name of the function. So that's what you see in the ABI file. So in the CTF challenge that you were playing, you were also given access to the ABI files. Why? Because so that you can go through it and you can understand what are the different types of functions which are available and which you can call. Now, once the smart contract has been deployed and you have access to the ABI file, how do you call these functions? That is another thing, right? So in order to call them, there are various ways, but the one which I learned was using React. So if you're familiar with React, you can create a React frontend. And this is a very simple one, just one button, which invokes the function that I'm interested in. So you can see there's only like default function. If you create a React app, there's a default function inside which I have this ABI. How do you, I'm using importing ethers and ABI I'm importing. And this is the way you import, and I have given an address. And then in this particular line that you see, console.log await contract io.get balance, the last line. So that await is because it is an asynchronous call. It takes some time to get process. That is the reason when you call, we have to wait for some time. And contract IO, what it is, this is an important section. So whenever, if I have done everything, set up everything correctly, MetaMask is set up correctly, and my address is correct, ABI is correct, then I can create a contract, and then I can call whatever functions I want to. So finally, it was time to call the function. So when I call the function, this transaction got initiated, and this is what I got. So if you take a closer look at it, you will see it says error overflow. So which means that by default, the compiler is handling integer overflow exception. So it detects overflow and it blocks it. But it was not there always. Since Solidity version 0.8 and onwards, this is happening. So whenever you are using, make sure, we all know by now, I think most of us know, whenever we are using any software, we should always use the latest versions, right? Because they have many security updates and many important updates. So we should use the latest version. And when you are using Solidity, make sure to use 0.8 version or higher, because by default, compiler takes care of blocking integer overflows. And if you want to read more about it, I have given a reference link. You can go through it. Now, this is about integer overflow. So next, that we are going to look about how did I leak the flag, right? What happened there? Data privacy. Is my data really private? What can we do? So the way I spoke briefly earlier, there are, we all know, if all of you have written any kind of functions, you know, we declare variables, we make them private, public, right? Modifiers are there. So if, what does it say? By default on the documentation, if you see it says private functions and state variables are only visible for the contract, they are defined in and not in derived contracts. So it's talking with respect to contracts, different contracts that we create. And it is very clearly giving you this disclaimer there itself. It's saying that everything inside the contract is visible to all external observers. So it is very clearly saying, just because you are making it private, don't assume that it is actually private, but anybody can see the data. And again, the link is there if you want to read more about it there. So this is another example of another smart contract. And we have two private variables in this case. So we have a message, we have a flag. Now what I'm doing is, there's a constructor wherein I'm setting the flag by default, right? So the flag has been set, and then I'm doing a get flag. There's another function which is get flag. So get flag is public, which means anybody can call this get flag function. And the moment they call it, it returns the flag which was set in the this constructor itself. Now, how do we check? Once a smart contract has been deployed, remember that you can never delete it. So unlike usual servers, wherein I have control over everything, I can go and modify things. Once you have deployed a smart contract, it's going to be there forever. As long as you know the address, anyone can access it. So how do we what are some of the things that we can do? So for example, you saw when we did npx hard hat deploy, we specified a particular network, right? So that network could be Rinkibai, that could be Goerli. So in this case, these addresses are real. If you want to try it out, they are already deployed. So you can also follow these steps and try it out yourself. So this is one of the address which is there in the Goerli network. Now ether scan or block scan. So you can go to block scan and it will automatically redirect you to either Goerli or Rinkibai depending on what network you have chosen. So it also shows you, let me show you. Okay, if time permits at the end, I'll show you. But for now, just remember, so because this is Goerli network, we can go to goerli.etherscan.io and enter this particular address. And then you will see different transactions listed. So whatever transactions you do, that is also recorded. So the moment you deploy a contract creation transaction is created. That is the first transaction always. And after that, whenever you call functions, especially functions where ethers are exchanged, right? So all of them are tracked and you can click on them and you can see what was the function called. And in case there were any variables or any data which was visible, you can also see that. So I think I'll show you this one. So you can go to block scan. And here, if you just know the address of a smart contract, you can just copy that. Oh. Pankaj, where is that screen? Okay. Okay, so this is the address and we are just going to do a search on it. So if you see, it is showing you both Rinkibai and Goerli. Why does it show? Because there is some kind of transactions that has happened in both the networks. So we are talking about Goerli testnet. So let's see what is in there. So if I go there, and if you take a note of this B letter, and there is a notification icon on top of that. So what does that mean? Which it means that even though there is something in this Goerli network, there is also something else which we might be interested in. So when you click on it, again, it takes you to this page. So if it is available on multiple networks, you will be able to see that. Now, in this case, you see this contract creation, what I mentioned. So which means I have just created this contract and there is no transaction which has happened on this yet. And let's take a look at this Rinkibai. So in this case, also here, this is just contract creation. In case there were more transactions, let's just click on one of them. And what I was trying to say at click to see more, it is this section. So whenever you, because we have only one transaction, contract creation, I click on that. And this page comes, which shows you transaction details. And if you click to see more, and scroll down, this input data section, here you have some input and you can click on view input as, and you do UTF-8. When you do that, it converts the hex value to ASCII value, and you can go through this data and see if there is anything which has leaked. Mostly if there is any kind of string which is there in your smart contract, most of the times it appears here. So this is where the flag was leaked. And this is one section. And this is also something which is available in the ABI files, which we saw earlier. So there also you have this data, but you will have to do convert it yourself. But in this case, in the online, this etherscan.io, it allows you to do this conversion easily by just selecting view input as UTF-8, right? So this is one place you should always check. So is there no such thing as privacy? My question was, how do I create my Web3 challenges if I just can't hide my flag, because my flag was always becoming visible? So what is it that I did to hide the flag and not make it become visible? It's more of a Indian jugaad, you can say. So I figured out there's a function which is abi.encode pact. And it is mostly used to concatenate, you can say, kind of strings, multiple strings. So even when I try to combine individual words, I noticed that those individual words were also appearing in that space, right, in the ABI file. So then I had to literally slice it down to letters so that even if it comes up as is, it's all jumbled up and it makes no sense to anyone. So it's more like an obfuscation thing. So you can see how I have written the flag, every letter, and have concatenated them. And string ABI encode pact is something that you can use, and that's what I had used to hide the flag. If I had not used it, anybody would have just taken the flag and got all the points. And this is how it looked after I used ABI encoded encode pact, right? ABI encode pact. This input data section looked like this. So you can still see a pattern. There's a V and some kind of pattern, but you can't exactly make sense of what value it is. And yeah, similarly, in the Rinky buy, this is another address. Let's take a look at this address and let's see. So you have this space here. You can paste. And again, you see there's this notification and I have this transaction hash. Okay. Let's take a look at this other address from. And here you will see there are a lot of transactions, right? So here also you see contract creation and then different addresses from where people were trying to reach and they were trying to invoke different functions. So let's say you pick any transaction, and if you want to see the details, you can go through them one by one. Yeah. So yeah, basically, that's exactly ABI encode pact is what I have used, and that's how this problem was solved. Now, different transactions, you can go through them one by one and just try to analyze what is there and what's not there. Now, how much time do I have? How much? 15. Okay, I have enough time then. So this capture the flag. All of you have mobile phone. I have shown you a few things, and you see this address. This was one of the CTF questions. So third challenge was this one. So I want to give you some time, and why don't you try to see what all information you can gather from this address that you see. I know it would be hard to copy, but this is available online. My slide is available online. You can access it at slides.com, Riddhi, Shree, Chaurasya, and you can select Web3. And I give you a minute, maybe minute or two. At least give it a try, and then I'll show you right here what it is and what we can do about it. So using this address, if you can find the flag. So So you don't have to write this contract address because, as I said, you can just go to the slides.com and yeah. Actually, it's not my laptop and I'm finding it a little hard. Pankaj, can you help me? I just want to put that address in a notepad and make it big. No, this one, the URL. Or can you zoom the screen? Okay. Anything. Just make it big so that it's visible. Yeah. 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 Thank you. So you can go to this particular slide and copy the address from there and give it a try. So I think a few people did manage to solve this challenge and it was amazing, but not many solves were there. The good part is you can do it from your mobile phone as well. At least few steps for sure. Not all the steps because you might have to write certain code. And I think I'll also start doing. So gradually, is there anyone who's still noting it down? Okay. So you remember block scan, right? I mentioned about it. So always the first thing that you want to do is you can go there and copy the address and try analyzing what is there. So this has few steps which you can call Web3 OSINT kind of thing. So a little bit of OSINT you have to do. You will have to try to figure out some of the information. And even if you can tell me some of the information that you could gather, that would be amazing. So I'll give you one more minute and then I'll also solve along with you. And I'll also see how far I can go. Because this is not my machine, so I think I won't be able to run everything. For my machine, HDMI is not working, so it was not able to connect. Did anyone find anything? How many of you are trying? Wow, amazing. No records found? Okay, so how do you know whether it's Guerli or not? It was given? Okay. Can I see your screen? It's in Rinkibai? Okay. 5 transactions found? Awesome. That is good. What did you find?
Yeah, Corelli address was there. Corelli address. I think we got 3 hashes. No, their total 5 transaction, 3 transaction have base 64 ABIs, and hint is there, set flag is there, give me more is there.
Anybody decode it because. Awesome. Okay. And what else was there? You're right. Yes. Yes. What do you think is give me more?
Hint, I think.
You're right. You're absolutely right. I think you should have
hints,
solved
No.
tomorrow. No, I mean, if you had tried and if you had known these things, you would have been able to solve it. Why no? Yes, you are giving the answers, and if you have reached those base 64 values, yes, you're on the right track. Even though it says go early, maybe it was by mistake. I mentioned that, but it does not matter because as I showed you, right, the notification icon tells you on which networks it found information. So if you didn't get anything in this one, you can check the other one if there are any transactions in there. So he rightly figured out in Rinky Buy there were 5 transactions, and if you go to that view input section, you found a few base 64 encoded values and few just dummy values to tell you that you are on the right track. So one of the base 64 value, can anyone tell me, other than give me more and set flag, what was the third base 64 value? Yes, absolutely. That is the link to ABI file. So because ABI is very important, if you want to access a smart contract, if you want to make a function call, 2 things are very important. One is the address. You need to know the smart contract address. And the second one is ABI file, because it defines what are the functions. Still 15 minutes. It was 20 minutes back then. All right. Time is moving very slow. Okay. No, ABI is. Yes. So in the ABI, now that you have the ABI file, the next thing that you can do, because all of you know that in ABI file, what do we have? We have functions. It tells you what all functions are defined in the smart contract and what are the inputs it expects. So you can take a look at it, and even if you don't take a look at it, the hints in the 5 transactions tell you call the particular function, get what was that? Cell article, I guess. Cell article, right? Get article, and it also says when you call me, say another base 64 value, which if you decode, it tells you give me more. What does it mean? Who can tell me? One thing is you can take a look at ABI file and then make a good guess. Other thing is you can just from the hints make sense out of it. So it says when you call me, cell article, say this. How do you say something to a function? Absolutely. So you pass it as a parameter value. So the hint was when you call that function, you have to say give me more, and you need to pass that value and you would get the flag. So that was the challenge. And I think ctf.winja.site is still up in case you want to solve some of the challenges. And we have not brought it down. So you can still go ahead, even though you won't get any more points, you won't get prizes. The winners will definitely be announced today during the closing ceremony. But if you want to try a few challenges, you can go ahead and try them out. Do you have any questions at this point of time? I hope all of you, my main message that I wanted to send here is I wanted to share my experience with smart contracts. What are the things I learned, right? So first thing, integer overflows don't work anymore by default. Compiler handles it for you. 0.8 onwards, Solidity 0.8 version onwards. The second is don't depend on private variables, blindly thinking that is going to protect your values. Private, it means has a very different meaning. So be very careful if you are putting anything in your function and it is sensitive, do not put it. If you want to just obfuscate, you can use string ABI encode packed function the way I did, but if there is any other better way, definitely make use of it. Now, this is all what I had to talk about. apart from this, I would also like to talk a little bit about Vinja. So Vinja is a community and I am a part of it, and it is open for everybody. So we are there on Discord. This is even on ctf.vinja.site, you can see our Discord server. Here, if you click on it, if you want to be part of it, you can click on it and you can join us. And it's not like there is one person who's monitoring and who's handling everything. It is open to the community members. And if any one of you sitting here has any idea, wonderful ideas, and you would like to implement, you would want to engage with other people in the community, you are absolutely free to come and talk to the existing volunteers, collaborate together, and do wonderful things. Few things that we do is on every Saturdays. Most Saturdays, I wouldn't say every, but most Saturdays, whenever any volunteer is available, we choose topics and we discuss about them with the community. So, for example, we put hack the boxes and we solve it together. We have an open discussion. So, all of you are invited to be part of it. We also have our website at vinja.nalcon.net. And here also, you will get few details about our past events and things that we have done, right? So you can click on the past events link and you'll get a few information about us. So that's all from my side. If you have any questions so far, please feel free to ask. I would be happy to answer them. Okay. If there are no questions, then I would just thank everyone, all of you, for listening to me. And I hope you found Web 3.0 interesting and you would go back and try it out yourself. This is absolutely, again, it's not totally decentralized. There is some centralization aspects to it, but then most of the things are decentralized, and just start playing around with it. Thank you, everyone. Thank you so much.
Thank you so much, Riddhi.